All right, this is the next part of 2.4 complex numbers. We're going to start off with something called the complex conjugate, okay? So the complex conjugate is pretty much the kind of like the opposite imaginary part with the same real that gets multiplied times, usually multiplied times the original. So it's when a pair of complex numbers are of this form, okay, a plus bi and a minus bi. So we're going to go right into, and this would actually be called a complex pair right here, okay? So we're going to go ahead and go right into an example, or several examples. It says multiply each complex number by its complex conjugate. So the complex conjugate for this one would be, and I'm going to put this in parentheses, would be 1 minus I. Okay, and then we just perform the multiplication. So it's just like the FOIL that we did earlier. So 1 times 1 is 1. 1 times negative I is negative I. Okay, I times 1 is going to give me positive I. And then I times negative I is negative I squared. Okay. We're going to simplify this so you can see that the middle terms are gone. So we have 1 minus, remember that I squared is negative 1, which is going to be 1 plus 1 equals 2. And that's it for that one. Okay, next one. We're going to multiply this one by its complex conjugate. So same as before, we're going to take the same real, so 4, and then change the imaginary, so plus 3i. Okay, and perform the FOIL operation. So 4 times 4 is going to give us 16. Okay, 4 times 3i is going to give us 12i. Negative 3i times 4 is going to give us negative 12i. And then negative 3i times 3i is going to give us negative 9i squared. So again, you can see that these two are going to come out to 0. This is 16 minus 9 times negative 1, because again, remember, I squared is negative 1. So we get 16 plus 9, which in this case is going to be 25. Maybe you're seeing a pattern at this point, okay? If you are, great. If not, then keep on paying attention. Next one. So we have 3 plus 6i. So I'm going to multiply times the complex conjugate by keeping the same real, so 3, and changing the imaginary to the opposite sign. We're going to FOIL, okay? So that's going to give us 3 times 3 is 9. 3 times negative 6i is negative 18i. Then we do the inside. 6i times 3 is positive 18i. 6i times negative 6i is negative 36i squared. Okay, these are gone. So we have 9 minus 36 times I squared, which is negative 1. So 9 plus 36 is equal to 45. Okay, last one. Same thing, we're going to multiply times the complex conjugate. Okay. Oh, wrong color. So I keep the same real, so 2, change the imaginary, plus 5i. Okay, same thing, we're going to FOIL, so I'm going to do all these operations here, and hopefully you're getting better at the FOIL. So 2 times 2 is 4, 2 times 5i is positive 10i, negative 5i times 2 is negative 10i, and negative 5i times positive 5i is negative 25i squared. Okay, just like all the ones before, these are gone. So we have 4 minus 25 times negative 1, because again, I squared is negative 1, which is 4 plus 25 equals 29. So based on these 4 examples, you can kind of see that the middle terms are going to come out to 0 because it's just the opposite sign being added together, which, comes out to 0. So all that we really need to look at, if you wanted to kind of skip some steps, okay, would be the endpoints where you're squaring. So if you think about it, this is actually going to be in the form of a squared, so whatever this is squared, right, plus the last one squared. Okay, so you're just taking this one and you're squaring it and you're going to add it at the end. So that's kind of a shortcut. Maybe I'll make you prove that. I think there's a problem that makes you prove that. So we'll see if that comes up in the homework. Okay. All right, moving on. Standard form of a quotient. So we should know by now that the standard form is that just a plus bi, okay? If we have something like this, then we need to make it into standard form. What we do is we multiply times the complex conjugate. And we do that by multiplying the denominator to get rid of the denominator, so to speak, okay? So here's how that is going to go. Here we go. So I'm just going to recopy this, a plus bi over c plus di, okay? And I'm going to multiply times whatever the conjugate is of the bottom. So c minus di, and then c minus di. Remember, I'm allowed to do this because this divided by itself is just 1, so we're really not changing any value here, okay? And then we're just going to go ahead and do the FOIL like we did in the past. So I'll put these in parentheses. So a times, we'll go ahead and go step by step. So we have a times c, which would be ac, okay? And then a times negative di would give us minus ADI. And you don't have to put the parentheses there if you don't want to. It's a habit. Okay, then we have the inside, so bi times c. So that's going to be plus bci, okay? And then bi times negative di is going to be minus bdi square, okay? All over, let me move this over just a little bit, all over this guy. So you should kind of know what this is going to be already, but we can go through it if you want. So c times c is going to be c squared. C times negative di is going to be negative cdi, okay? The middle part is going to be positive cdi, okay? And then the last one here is going to be minus d, minus d square I square, okay? I can put that in parentheses if you want. So we can see that, let's go ahead and simplify a bit. We can see that these two are going to be gone, okay? And what else can we do? Okay, let's go ahead and start combining on the top now. So we're going to have on the next step, and this is just generally, okay, guys? So we're going to do some actual numerical examples in a bit. So in the numerator position, we can combine these two right here. I can combine these two like the following. So I'm going to leave my AC in front. So AC, okay? And I'm going to do, I guess I won't skip the steps. I'll go ahead and show you the steps. So it would be plus, okay, a negative AD plus BCI. So all I'm doing is I'm kind of like factoring out the I, okay? And I just put a plus because I don't want to make things anything weird with the signs. So I just copied the sign so far, okay? And then we have minus BD. Remember that the I square is negative 1. Okay, this is negative 1 right here. So be careful with that. Remember this part is this part, okay? And then on the bottom, we have C squared minus D squared, again, times negative 1. Because again, the I square is negative 1, okay? We're going to continue simplifying if we can. It looks like I can simplify this part. I'm going to go ahead. I think I can squeeze it in here. So we're going to do AC. And I'm going to change the order here just because this does look a little weird to me. So I'm going to go ahead and do BC minus AD. So plus BC minus AD, I, okay? And then these two right here is a negative times a negative is going to give me positive. So it's going to be plus BD, okay? Over the bottom, so C squared plus D squared, because again, the two negatives make a positive. And we can go a little bit further because we want it to look like a standard form. So we want that real part and the not real part, okay? The imaginary part. So this is going to be AC. I'm going to move the BD up to the front. So plus BD, okay? And then this part right here, plus BC minus AD times I all over C squared plus D squared. All right, and then from here, we could kind of stop here, but I want it to be real part and, imaginary part. So I'm actually going to separate this like so. AC plus BD over C squared plus D squared plus, I'm kind of taking these two apart. Remember, they have the same denominator, so we're allowed to do this, okay? BC minus AD, and this is going to go in parentheses, and there's my I over C squared plus D squared. And this is our final result. It's kind of a lot of work, but this is like a more general form, okay? And from here, we can see that this part right here is the real part, and the part with the I, this part right here, is going to be our imaginary part. Okay? All right. Lot of math here. Okay, let's go ahead, and you got to go really carefully so you don't mess up. Let's go ahead and do some actual numerical examples now. See how this works. We got two of them up here. Okay, it says a quotient of complex numbers in standard form. So we're going to go ahead and hopefully this all fits here. Do the first one right here. So we have 2 plus I and 2 minus I in the denominator. So the first thing we want to do is multiply times the complex conjugate of the denominator. So it would be 2 plus, that's an I. 2 plus I, 2 plus I. Okay, where you can see this is an I. And we're just going to multiply. So I'm going to put this in parentheses so we can go ahead and do our FOIL. I'm going to try to not to go too fast. So 2 times 2 is going to give us, I'm going to go ahead and just kind of go here, okay? It's going to give us 4. 2 times I is plus 2I. I times 2 in the middle here is going to be another plus 2I, okay? I times I is I squared, okay? All over the bottom. So again, if you don't remember this pattern, you can go back. I'm going to go through the FOIL just to make sure I get all the steps. 2 times 2 is 4. 2 times I is positive 2I. Negative I times 2 is negative 2I. Negative I times I is negative I squared. Okay, so these are gone. And this is going to be equal to, I'm going to combine just right here really quickly. In the numerator, we have 4 plus 2I plus 2I is 4I, okay, plus I squared is negative 1. In the denominator, we have 4 minus I squared. So I'm going to change that to negative 1 as well, because remember, again, I squared is negative 1. And that's going to give us, we're going to combine the top. So we have 4 and negative 1, which is going to give us 3 plus 4I all over. This becomes a positive, so 4 plus 1 is 5, okay? And then we want to separate it so we have our real and our imaginary. So this is the same as 3/5 plus 4i over 5, where our 3/5 is our real part, so this one is our a, think of it as the real, okay? And the 4/5 I, so this part right here would be our imaginary. I think I forgot an I in there, so kind of like our B part, okay? And that's it for that one. Let's try one more, and then I think we have just a few more examples, and that'll be it. So 2 plus 4i over 4 minus 2i. I think I just made this one up, so let's see how complicated it is. Let's see. We're going to multiply times the complex conjugate, so this would be 4 plus 2i, okay? 4 plus 2i. I'm going to kind of put a little division line here so we don't confuse that. So let's go ahead and multiply. So oh, my pen is getting stuck here. There we go. So 2 times 4 is going to give us 8. 2 times 2i is going to give us plus 4i. Okay. 4i times 4 is going to give us 16i. 4i times 2i is going to give us 8i squared. Okay. For the denominator, we have 4 times 4, which is 16. 4 times 2i, which is 8i. Negative 2i times 4, which is negative 8i. And then negative 2i times 2i, which is negative 2i squared. Okay? So from there, we're going to go ahead and simplify. So it looks like in the numerator we have 4i and 16i here, okay, which is going to give us 20. So 8 plus 20i plus 8 times I squared is negative 1. Okay, here, I'm going to circle those so we don't forget those, okay? All over, and the denominator, we can get rid of those, okay? So that's going to give us 16 minus 2 times negative 1 again, because I squared is negative 1. I think I'm going to change colors here because it's looking a little bit, I don't want it to be too confusing here. So we'll use pink. All right, so in the next step, we can combine a bit. Well, actually, no, we have to multiply. So 8 plus 20i, 8 times negative I is going to give us negative 8. Okay, all over 16 plus 2 in this case. Probably not the best color choice there. Let me go over it real quick in case you can't see. So 8 plus 20i minus 8 all over 16 plus 2, okay? And then we have, in our next step, we can combine the 8s. So you can see that the 8s are going to come out to 0. So we're left with 20i over 16 plus 2, which is 18, which can be simplified by 2. So that's going to be 10i over 9. And that's it for this one. You can see that we don't have a real for this one. So this would just be a pure imaginary number. Okay, since the real part, there's nothing there. They kind of cancel each other out here. They came out to 0. Okay. Okay, so moving on to the last topic here in this section of chapter 2, we have complex solutions of quadratic equations. So recall that the square root of a negative number can be written like the following. You can factor it like so, okay, and then from here you can even further separate into 2 different square roots, where you can see right away that that square root of negative 1 is going to give me the I, okay? We can write it like this, or we can write it like this. I think your web assignment is probably going to ask for it like this, so we'll have to double check on that. Just make sure that if you do it this way, your I is on the outside of the roots, not underneath, because that's not the same thing. Our definition here, we have the principal square root of negative a, so it's kind of what I did up here. If a is a real number and a is positive, so in other words, a by itself there is positive, then the negative version of this, and we take the square root of that, is going to give us square root of a times I, or square root of a times I this way. I think I meant to put the I in front, so that's what I meant to put. So, or I square root of a, okay, something like that. So we're going to go ahead and simplify the following. I'd like to make a note on this example that usually when we're dealing with numbers like this, okay, we can just multiply them straight out, but if they're both negative, so if these are both negative, we have to kind of follow a different pattern. We have to consider that imaginary part of it. So here's how this one's going to work. I'm going to change these individually first. So we're going to have square root of 3 times negative 1. And I guess I can put it like this. Okay, sorry, I wrote some wrong numbers on here earlier. I don't know what, I was looking at different problems again. So I don't want to confuse you. So 3 times negative 1, okay, times the square root of 12 times negative 1, okay? And we're going to go ahead and separate these two now. So this is going to be equal to square root of 3 times square root of negative 1, okay, times, same thing over here, so square root of 12 times square root of negative 1, okay, and we can see from here that our square root of negative 1, so these two are going to be equal to negative 1, okay, so, I'm sorry, not negative 1, to an I. So let's go ahead and rewrite this again. So we have square root of 3 times, I'm going to put these two together now, okay, square root of 12 times our first square root of negative 1 is going to be that I. So I times the second square root of negative 1. So times another I. And then from here, we can go ahead and simplify even further by doing this. So I'm going to go ahead and put, now that I have these both positive, I can put them underneath the same root. So 3 times 12, okay, times I is just I squared. I'm just going step by step here, okay? So if you know the answer, go ahead of me. 3 times 12 is 36, okay? The I square is equal to negative 1. Square root of 36 is equal to 6. This right here is positive 6. And negative 1 is just negative 1. So 6 times negative 1 is negative 6. Okay? And that is it for this example. Let's go ahead and look at a couple more. I think I wrote these on the back. Yeah, I wrote these back here. So let's look at letter B now. This is a subtraction problem, so we're going to have to do a little bit of, well, you'll see in a bit. So we're going to do the same thing where we're going to rewrite these in terms of our square root of negative 1s. Okay, so I'm going to separate this first one as 48 times negative 1. I'll keep it as a parentheses just so we don't confuse the dots and the lines. So 48 times negative 1 minus square root of 27 times negative 1. Okay, and then we're going to separate them. So we have the square root of 48 times the square root of negative 1 minus the square root of 27 times the square root of negative 1. Remember that this is just equal to an I. Okay, so let me rewrite that. I have the square root of 48I minus the square root of 27 I, okay? And then I have to, since we're not multiplying here, I can't exactly combine these two. So what I'm going to do is I'm going to simplify the radical. And this is a part where if you don't remember how to do this, you might have to come to some tutoring sessions, or maybe we can go over some of these in class. But what we're going to do is we're going to rewrite this 48 in terms of a perfect square. And whatever the perfect square is, we can pull out. So 48 is the same as, let me see, what's a perfect square in here? 16 times 3, I believe. Yeah, 16 times 3. There's my I, okay. Minus 27 is the same as 9 times 3. There's my I. I'm just bringing the i's along with it. And the way it works is you take that perfect square, so 16 and 9, and you pull out the root of that. So the square root of 16 is 4, so that goes out here. Okay, so now we have 4 square root of 3i minus square root of 9 is 3. So 3 square root of 3i. So whatever we had left in here, those stay on the inside. Okay, that's what I'm doing here. It's kind of a super quick lesson on that. And then from here, we can see that both of these have in common the square root of 3i. They both have this in common. So you can kind of like factor that out, so to speak. So I'm going to have square root of 3i, and then whatever's left over is that 4 minus 3, okay, which is going to give me square root of 3i times 1, which is just the square root of 3i. I'm sorry, I kind of switched colors on you there. But yeah, that's it. Another way to think about this one, you have 4 of these and 3 of these, so 4 minus 3 is just 1. Okay, simple as that. All right, last problem, and this is actually a quadratic formula problem, which I'm so glad we finally have because we haven't really practiced quadratic formula in this class yet, even though you have technically seen it. So we're going to solve this quadratic equation using quadratic formula, and we're probably going to get a complex number in there somehow. So just as a reminder, okay, so recall, I'll put a box there. Recall that the quadratic formula is as follows. By the way, if you do plan to be a mathematician of some sort or engineering, this is a great formula to memorize. There's lots of ways to memorize it. All right, so negative b plus or minus the square root of b squared minus 4ac over 2a. This is the formula, okay? So if you don't remember, I'm going to give you a quick review. This part right here is called the discriminant, okay? When the discriminant is less than 0, that means it's negative, right? That means that the graph has no real solutions. So when that happens, that's when we use complex numbers. So we're going to go ahead and solve this one and see how that works, okay? So just as a reminder, this is A, this is B, and this is C. So I'm going to go right into it. So x is equal to negative b would be negative 14, okay, plus or minus the square root of b squared, so 14 squared, minus 4 times a, so 8, times c, which is 9, all over 2a, which in this case is our 8. You want to make sure everything is plugged in correctly because this is where most of the mistakes tend to happen. So negative b, b squared minus 4 times a, we're good, and then c, 9, okay, over 2a, so 2 times 8. So it looks like we're good to go, okay. Typically, I like to calculate this part first, just kind of on the side. So 14 squared minus 4 times 8 times 9. 14 squared, I always forget what that one is. I want to say 2 something. No, completely wrong. 196. 196 minus 4 times 8 is 32. And 32 by 9 is 288. For here, you can use a calculator if you'd like. They're just simple calculations. So if you subtract these two, we get, oh, Wrong calculation. We get negative 92. Okay, so negative 92 is what's going to go in the parentheses. So we have negative 14 plus or minus the square root of negative 92 over 16. So it's going to be kind of an ugly fraction, but that's okay. That is okay. So from here, we want to simplify this part now. So I'm going to see if I can simplify square root of 92. And there's a lot of side work involved here. Let me see. Can I divide this by 4? I know I can divide it by 2 because it's an even number. But it looks like I can divide it by 4 also. So this is the same as negative 4, or we'll do negative 23 times 4. Okay, so that negative right there, remember, let me switch colors here so we can see a little bit better. So that negative is the same as saying negative 1 times 23 times 4. And I really hope these calculations are correct. It's going kind of fast here. So you can see that the negative 1 is going to be that I that we're talking about. Okay, so it's going to be square root of 23 times 4, and then the I. To simplify even further, 4 is a perfect square, so if I take the root of 4, it's going to be 2 square root of 23 I. So this is going to replace this right here. And again, if this part is a little confusing for you, just this process right here, we can definitely review this in class. We're just breaking down the radical here, okay? So let me kind of go back a little bit straight here. So after we have that, we're going to replace it. So we have negative 14 plus or minus. In these problems, I like to put the I in, well, we can put it on the back, it's fine. So 2 square root of 23 I all over 16, okay? And we can simplify because you see that the 14, the 2, and the 16 are all divisible by 2. So here I'm gonna write divisible by 2. So we get negative 7 plus or minus, we don't have to put the 1, square root of 23 I over 8. And at this point, we can stop. And that is it, guys, for this video.